Okay, till now we have seen, we have covered two topics in your circle. Okay, we have seen area of the circle, area of the semicircle, area of the quadrant. Then we have seen area of the sector and area of the segment. Okay, now today we are going to cover the area of the combination of plane figure. Okay, area of combination of plane figures means two, three combinations of figures will be there, and then you have to find out the area of the shaded portion or the specified area just mentioned in the question. Okay, so we'll see the combination of some of the figures and how you are going to calculate the area. Okay, understood? Now, some important formulas. Okay, and you already know circle formula. We have already seen the formula of the circle, the formula of the semicircle, the formula of the quadrant, area of the quadrant, in fact. Okay, and the area of the sector and area of the segment. Okay, now some of the figures that you can, with the combination of the figures here, you'll see. So area of the triangle. Okay, we already know the area of the triangle that we have covered in the triangle chapter, that is half base into height. Okay, and then area of an equilateral triangle. Okay, specify there are areas of this isosceles, but generally you'll feel like you'll have the area of the equilateral triangle. So area of the equilateral triangle is √3 upon 4 into side square. Okay, now area of the rectangle, length into breadth, area of the square is side square. Okay, now the first combination that we will see here, type 1 combination. Okay, that when combination of a circle, a semicircle and square. Okay, means circle means many circles will be there, semicircle and a square can be there, rectangles can be there. Okay, these combination will be there. Okay, are given. So how we are going to solve? Okay, now first question here. Okay, generally here no theory is there. You just need to know what is the formula. Okay, to find out the area of the different shapes. Okay, if you know the formula of the different shapes, then you just need to apply the formula and calculate the area. Okay, sometimes you have to just look in the figure and find out how you are going to find out the shaded portion area. Okay, but generally it will be very clear. Like here in this figure, you see that you have to find the area of the shaded portion, that is the gray one. Okay, so how you are going to find out? Simply you are seeing there is a square ABCD. It's written in the question that you have to find, and ABCD is a square. Okay, of side 12 centimeter. This side is 12 centimeter. Okay, and this is a square. So we know now we have to find out the area that is left after drawing inside the square after the 4 circles. Okay, so what you can see here, that there are 4 circles. Okay, now all the circles are touching each other. Okay, so here if you see here, observe here, so it is already given that this is 12 centimeter. Okay, and now you can see individually there are 4 circles that are touching each other. So in fact they are equal circles. Okay, yeah, you can see here all the circles are equal. So its diameter, the diameter of one circle will be half of the circle, half of the side. Okay, so it will be 6 centimeter. Yes or no? And therefore the radius will be more half than 3. It will be 3 centimeter, and the same radius will be of all the circle. Okay, so how you are going to find out the area of the shaded portion? Area of shaded portion is equal to area of square ABCD minus area of edge. There are 4 squares. Okay, so minus 4 into area of circle. Okay, now so area for shaded portion will be equal to area of square ABCD. Area of square is what? Side square minus 4 into area of a circle, pi of square. So side square is 12 multiplied by 12, and this is 22 by 7 into r square. R is your 3. Okay, now you can calculate the area. Okay, any doubt here? Safia, Roniel, any doubt here? In fact, you can do the calculation also. Okay, I'm going to 7. We are going to calculate this whole. It will be in points. Okay, now this you can calculate it. Okay, solve this. Okay, any doubt? One more question we'll see here. Then we'll see the different type of combination. Okay, now design, you can see the flower. You have to find out the area of that flower. Okay, where ABCD is a square of side 10 centimeter. Now this is a square of side 10 centimeter. Understood? And semicircle are drawn with each of the side as diameter. Okay, there are 4 semicircle is this. One semicircle is, wait, I'll use different colors for no confusion. One semicircle is this. Okay. Now one semicircle is this. And semicircle is this. Okay. Now, semicircle diameter is 10 centimeter because it is drawn with the help of the side. Okay, which each of the side is diameter. Okay. Now, how can you find out the shaded portion area? Sophia, Rudronian, any hint how you're going to find out the shaded portion area? See, if for the area of the remaining portion as 1, 2, 3, 4. Okay, why? See here, the area of first and second. How can you find out the area of first and second? Okay, in the complete square, if you are going to subtract the semicircle with green color and orange color. That's why I made 4 different colors. Okay, semicircle with A. You can write here O, A, O, D, and B, O, C. Okay, these two semicircles. So area of first and second will be area of square minus area of AOD and BOC semicircle. Okay. Now area of square will be 10 centimeter, 10 to 10. That will be 100 minus area of the semicircle. Area of the semicircle is what? 1 by 2 pi r square. So yeah, pi r square 3. Yeah, will be your 5. Yeah. Any doubt here? And semicircle area will also be same for both of them. Okay. Yes. Okay. So it will give you 100. 2 will be capped. You're going to multiply. What happened? That's fine. Maybe issues there. Okay, so it is 100 minus 78.5. You are multiplying, so your answer will be 2.5 centimeter square. Okay, so this is the area of first and third region. Okay, first and third region. Now, similarly, we can find the area. See how can you find out the shaded portion? What I'm going to do, I'm going to find out the area of first, second, third, and fourth, and then I'm going to subtract it from the area of the complete circle ABCD to get the area of the shaded region. Okay, and for that I am finding. And how can we find out the first, second, third, fourth portion area? So we have already calculated the area of first and third. Similarly, then the same way we are going to calculate the area of second and fourth by subtracting from the area of complete circle the area of 2 semicircle, that is AOB and DOC, the pink color and the blue color. Okay, area of second and fourth equal to what? Area of square, that is 100 minus area of the 2 semicircle, that will be again 78.5. Okay, and it will give you 21.5 centimeter square. Okay, understood? Any doubt? Now we need to find the area of the shaded portion. Area of shaded portion is equal to area of ABCD minus area of first, second, third, and fourth. Okay, so it will be equal to area of ABCD is already we know 100. Now area of first, second, third, fourth will be minus 22.5 plus 21.5. Okay, so we'll get 100 minus 43 it is. Okay, so it will be equal to what? 57 centimeters. Okay, any doubt in these questions? Sapki and Rudronian. Okay, now let's see. When combination of 2 concentric circles are given. Okay, when there are combination of 2 concentric circle, means concentric circle we already know what it is, that the 2 circles whose center is same. Okay, they are called concentric circles. Okay, now we are seeing the questions that are based on 2 concentric circles. Okay, so now here we have to find out the area of the shaded portion. In the given figure, sector of 2 concentric circle of radius 7 centimeter and 3.5 centimeter are shown. Okay, now we have to find out the area of the shaded portion, that is this portion. Okay, this portion area we need to find out. Okay, we already know the area of the sector. What is the area of the sector? That is theta upon 360. Theta is the angle that sector make at the center. Theta upon 360 into pi r square. Okay, so what we are going to do to find the shaded portion area, we need to find out bigger sector area, that is BOA, and then we are going to subtract the area of the smaller sector DOC. from this to find out the area of the shaded portion. Okay, so let's see. See area of the sector having radius 30 centimeter, and for both, because they are concentric circles and the same sector is there, so 30-degree angle they are holding at the center. Okay, area of the center. Okay, so what will be the area? Area of sector is theta upon 360 degree into pi r square. Okay, so area of shaded portion, area of sector. Okay, fine. Okay, so area of bigger sector, how you are going to find out? Angle 30 degree only, 30 upon 360 degree into pi r square. Okay, in fact, 30 upon 360 you can take common, into pi also you can take common, and then r square, 7 square minus what is there? The smaller one is 3.5 square. 3.5 you can write it at 7/2 square. Okay, understood? Now it will be 12 into the value mentioned like 22 best. Okay, so after calculating this, you'll get the area. Okay, cancel here, and then you have to multiply and cancel here also. Okay, 11 by into 7, 49 minus 49 by 4. Okay, after this, you'll get final area as 9 decimal. Okay, now one complete concentric circle you can see here. Here are your question. Any doubts, Safiya and Rudronial? You don't respond. Know that whether you understood or not. Very good. Is there? Just a minute. Okay, let it be where it is. Now, in figure AOB is flower. This AOB, you can see it is a segment. Okay, sorry, a sector. So AOB is a flower bed in the shape of a sector of a circle. Okay, so AOB is the area covered by the flowers. Okay, and the angle that AOB is holding at the center is 60 degree, and the radius of the circle, that is AO value, is 40 meters. Okay, now find a 15-meter wide concrete track is made as shown in the figure. So concrete track, this is the concrete track. Okay, and the width is 15 meters. Okay, now so you can radius of the smaller circle. Okay, if you minus 15 from 40 meters, you will get the radius of the smaller circle. Okay, flower bed is made. Okay, now rate of making the flower bed is 2.40 per meter square, and rate of making the concrete track is rupees 20 per meter. Okay, now we need to find out the amount you spend doing the complete means the flower bed also, and additionally the making of the concrete track. Okay, the total cost required. Okay, so we need to find out. So before that, we need to find out the area. Okay, after finding out the area only, we can multiply with the cost and find out the complete cost. Okay, now since AOB is a sector, we are going to calculate the area of the sector, and then we can find out the area of AOB. Okay, so let's see. We are going to find out the area of the sector. Okay, so area of AOB is equal to area of AOB, as it is a sector, so it will be what? Theta upon 360 degree into pi r square. Okay, pi r square. Okay, so theta here it is 60 degree upon 60 degree into pi. It is already mentioned we have to use 3.14, so we are going to use 3.14 into 3.14 into 4 Now after area, okay, required for or you can say amount spent for what is the amount that is used, what cost 0.4 is cost of making concrete track. So concrete track, the major sector, or no, this is a major sector, bigger, and this is the area of the major sector. From that, we are going to subtract the area of the minor sector. Okay, sorry, area of the smaller, the area of the concrete track. Okay, so let's find out here. Area of concrete track is equal to, let's say, Okay, my screen is okay. So this is the area of the major sector of the outer one. Okay, now we are going to subtract the area of the minor. Okay, again the same angle it will be holding in the center. Okay, multiplied by pi multiplied by your 40 minus 15. Okay, so it will be 25. It will be 25 square. Okay, now you're going to calculate the area from here. So it will be, after multiplying, you'll get the value as this. Okay, this is your answer. And you have to find out, then you have to find out the total cost. So cost is 20 per meter square to make the concrete track. So we are going to multiply with 20 with the area of the concrete track, and we'll get the answer as 51,025 rupees. Okay, and then we are going to add both the cost. Okay, both the cost to get the total cost. Okay, understood? Now combination of circle and triangle are given. Okay, if the combination of circle and triangle are given, how you're going to solve? Okay, so here a memento is made as shown in the figure. Its base PBCR. Okay, I'm coloring it PBCR. This portion. Okay, this portion area you need to find out. So it is clearly, you know, that you need to find out the area of the triangle. Okay, actually you need to find out the cost of making this with a silver color or silver with silver metal. Find the total cost of the silver plating. Okay, and the cost is already mentioned, that is rupees 20 per centimeter square. So before that, for finding out the cost, we need to find out the area. And how we can find out this area PBCR? We can find out, first we have to find out the area of the bigger figure, that is a triangle, and then from the triangle we can subtract the area of the sector APR. Okay, so that we can get the area of the PBCR. Okay, so it is already mentioned the area of the sector. You can calculate how. See, it is holding 90-degree angle at the center. So this is a right angle triangle, half base into height. So base is your AC. You can treat AC as a base and AB as a perpendicular. Okay, anyone? So half base into height. So it is same, 7 plus 3, 10. Okay, so it will be what? Half 10 into 10, 100. So that will be 50 centimeters square. This is the area of triangle. Okay, area of triangle. Now area of sector. Sector will be equal to 90 upon this. That will be 1 by 4 pi r square. Pi r square. R will be 7. Okay, 77 by 2 centimeter square. Okay, now you need to subtract from this. So 50 minus 77 upon 2. You're going to solve this and you'll get the area. Okay, so okay, and then you have to multiply with the cost. What is the cost? That is 20. Okay, multiply with this. So 23 multiplied by 230. That is 230 rupees. Okay, understood? We just need to know the formulas, and you can just you have to put the values in the formula. Okay, now here also similarly triangle and circle. So find the area of the shaded region in figure. That is what is given here. Value AC. AC is 20 centimeter and AB is equal to 15 centimeter. Okay, this is your 15. No, sorry. This is your 15 and this is your 20. Okay. And O is the center of the circle. Okay, so you have to find out the area of the shaded region. So yeah, for finding out the area of the shaded region, you can see here it is a right angle triangle. Okay, it is a right angle triangle. So you can find out the area of the triangle. Okay, half base into height, and this complete is a semicircle. Okay, so in the from the semicircle, if you are going to subtract the area of the triangle, then you will get the area of the shaded region. Okay, so area of triangle, area of semicircle, area of semicircle. What is the area of semicircle here? 1 by 2 pi r square, which is equal to 1 by 2, 22 by 7 r square. Okay, first you need to find out the r. How can you find out the r? See, it is following, it will follow the Pythagoras theorem. So R will be equal to root 20 square, okay, plus 15 square. Okay, so R will be equal to what? R will be equal to 25. Okay, it is 625 you'll get, and we'll take the positive value. So 25 into 25. Okay, 11 into 6 20. Okay, now area of the, this is your area of the semicircle. Okay, now we need to find the area of the triangle. Yes or no? Area of the triangle. Let's see the area of the triangle also. Area of triangle is equal to half base into height, half base into height. Okay, now you need to subtract this from this. So shaded region, area of shaded region is equal to 11, 7 into 6 to 5 subtracted by 1 by 2 into 20 into 15. Okay, you're going to solve this and you'll get the area. Okay, so it is 100t and it will be 7. Okay, calculate this and you'll get. The last question is what? When combination of quadrant of circle, and after this we'll be completing the chapter. Okay, so when combination of quadrant of circle and triangle square is given. Okay, now here in the given figure, in the adjoining figure, OACBO represent a quadrant of a circle of radius 4.5 centimeter and with center O. Calculate the area of shaded. Now shaded region is this. This is just a shaded region. Okay, it is not physically, you know. This is a shaded region. So clearly we are going to find out the area of the quadrant, and from area of the quadrant we are going to subtract the area of the triangle to get the shaded portion area. Okay, so area of the quadrant will be what? 1 by 4 into pi r square, 4.5 square. Okay, now subtracting area of the triangle, that is half base into height. Okay, and after calculating you'll get the area of your shaded portion. Understood? I'm not doing the calculation, I've just written it. Now here, square OABC is inscribed in a quadrant OPBQ of a circle as shown in the figure. OA is equal to 14 centimeter. Now again here also shaded portion is this one. So here what we need to do, again we need to find out the area of the quadrant, and from that we are going to subtract the area of the square. Okay, so but here radius is not given. We need to find out the radius. Okay, so how can we find out the radius? This is obviously, this is a square, so all the angles will be 90 degree. Okay, so you are going to find out BO, or you can say radius. In fact, I'll write radius is equal to, by Pythagoras theorem, or you can say the diagonal of the square is equal to side root 2. Okay, side root 2. So side value is 14 root 2, okay, centimeter. So this is your radius, and from here you are going to find out the area of quadrant. Area of shaded region is equal to area of quadrant minus area of square. Okay, so area of quadrant is what? 1 by 4 pi r square. So r is 14 root 2 square. Okay, minus area of square will be 14 multiplied by 14. Okay, understood? You are going to solve this and you'll get the area of the shaded portion. Any doubt in this section? We need to find out the area of the combination of figures. Safia and Rudronial, any doubt in this section?
No, ma'am.
Safia, do you have any doubt? No. So this is all. We have completed now the circle chapter, and I think I missed. So you are not having any assignment related to this area of circle. Okay. So from Tuesday, I'll start with area of circle assignment. Okay, and after that we'll be having a test. Okay. So the next chapter, which chapter shall we start? I think arithmetic progression is there, construction is there, surface area and volume is there, and statistics. These chapters are only remaining. 1, 2, 3, 4. So what should be the next chapter? Which chapter you will prefer? Safia, Rudronial, say something.
Areas related to circle.
Areas related to circle we have completed just now.
Oh, sorry, I thought that was circle.
Surface area and volume, you mean to say?
Yes, ma'am.
So surface area and volume we may start. Okay.
You said that we do arithmetic progression.
Arithmetic progression. Okay, you want arithmetic progression.
Yeah.
Daniel, is it fine? We'll go for arithmetic progression.
Yes, ma'am.
Okay, so we'll go with arithmetic progression, and then after this we'll start with surface area and volume. Okay, fine. And go through your assignments also, your this area of circle assignment, okay? So that if you have any doubt in this question, so we can solve it, and after that you'll be having a test, okay? Area related to circle test. Okay then, bye bye. I'll see you on Tuesday.